oxides of phosphorus, we'll see one by one. P4O, P4O2, P4O3. This number of oxygen will keep on increasing, and finally we'll be having P4O10. Okay, in between this we'll be having two oxides of phosphorus, P4O6 and this P4O10. P4O10 is a dimer of P2O5, whereas P4O6 is a dimer of P2. Okay, the basic question for this oxides of phosphorus is what? We have to know how many POP bonds are there, how many lone pairs are there, what is the hybridization of phosphorus, what is the hybridization of oxygen. So basically we need to understand the structure of these oxides. So in order to understand the structure of this oxide, first of all we should know the structure of P4, that is white phosphorus. White phosphorus. It's very simple, you can remember an example of white phosphorus. It is having a kite-like structure. Okay, it's like phosphorus, phosphorus, phosphorus. Just join them by a single bond. Okay, so there are total 6 pp bonds. How? 1, 2, 3, 4 and 5th one. Now, if we have to make phosphorus tetraphosphorus monooxide, simply you have to remove a single sigma bond and you have to put a oxygen. You have to place an oxygen. By placing an oxygen, you should keep in mind it should not be like that, completely flat, because the bond angle becomes 90 degrees. Bond angle becomes 90 degrees. And here, if you just carefully observe, oxygen is 1 lone pair, 2 lone pair, 1 sigma, 2 sigma. So 2 sigma bonds and 2 lone pair. So the hybridization of oxygen is sp3. And if oxygen is sp3 hybridized, its bond angle should be 109 degrees. But since 2 lone pairs are there, so bond angle will reduce to 2.5 for each lone pair. So there are total 2 lone pairs. So the bond angle will reduce by 5 degrees. So it will become 104 degrees. So you should never draw structure in. Okay, so very simple thing about formation of oxides of phosphorus is what? You have to remove pp bond by POP. Simple addition of oxygen inside a single pp sigma. Okay, now let's continue further. Like if you want to make P4O2, simple remove this one. We can substitute an oxygen over here like this. P4O3 then. Okay, same thing like again over here. So this is P4O4. Now if you want a 5th one, you can do like this. If you want a 6th one, remove this one and you can get it. This is all about the structure of P4O6. Total there are how many oxygen? 6. 1, 2, 3, 4, 5 and this one is the 6th one. Now what about the other 4? Like if you are talking about the oxides of phosphorus P4O10, then where we can place the other 4 oxygens. Okay, so if you just look at the structure carefully, and if you know about phosphorus, phosphorus is an element of nitrogen family, which are having general electronic configuration NH2 and P. And since phosphorus belongs to the 3rd period, it is having electronic configuration 3s2 3p. So there are total how many electrons in the outermost shell? 5. So just count it. And it's phosphorus. So 1, 2, 3. And this one is the lone pair. Is that clear? So there is a lone pair associated with each phosphorus. So here, even this one is the lone pair, this one is the lone pair, this one is the lone pair. So total how many lone pairs? 4 lone pairs. Now, what phosphorus can do? Phosphorus can form 1 sigma and 1 pi bond with a single oxygen atom. It is somewhat like now you should also know there are how many number of lone pairs present on the double bonded oxygen. they can ask like, what is the hybridization of oxygen in P4O10, which is doubly bonded. How many doubly bonded are there? 1, 2, 3, and 4. And on single oxygen atom, how many lone pairs are there? 2. So 2 on a single oxygen atom. So there are total how many? 4 are there. So it will be 2 into 4, total 8 lone pairs. 8 lone pairs over what? Double bonded oxygen atom. If we go in detail, what oxygen can do? Oxygen can take these two pair of electrons. Like this is the pi bond. This is the pi bond. This is the sigma bond. What oxygen can do? Oxygen can take these two electrons and it will get a negative charge because this electron completely belongs to this oxygen, but this one is of phosphorus. So oxygen can pull these electron of phosphorus due to its high electronegativity. Now, let's talk about the basic structure of oxides of phosphorus. So first you have to draw the structure of P4, then you have to replace a sigma bond by POP bond. So basically, this is the structure, and on the basis of these structures, like any one of them, like P4O still it can be till P4O10. They can ask you anything related to sigma bonds, related to POP bond, related to hybridization. So let's first talk about the hybridization. If you're talking about phosphorus, just count the number of lone pair plus bond pair. On bond pair, that to which one? Sigma bond. This is the best formula for what? Hybridization. So this one is the sigma. Okay, this one is the pi. Okay, sigma. And this one is the sigma. So total how many sigma are there? 4 sigma and 1 pi. 4 sigma and 1 pi. So hybridization is sp. So single phosphorus is having hybridization of sp. And when you're talking about oxygen, just count it. There are the lone pairs. How many lone pairs? 2 lone pairs and 1 sigma bond. So hybridization is sp. Exactly. So now they can ask you even the question that are total how many POP bonds. How many POP bonds? You just know the structure. I have told you how to draw the structure, and then you can just count it. Okay, it's a very simple question. You can have POP bond, POP. Exactly. POP 1, POP 2, POP 4, POP 5, POP 6. So there are total 6 POP bonds in P4O10. In the same way, rather than asking about P4O10, they can even ask you about P4O6. So the simple strategy is what you have to draw the structure, and you can come to know about the hybridization, bond angle, at the same time number of bonds. Now sometimes when the question comes, how many lone pairs are there over the oxygen atom, entire oxygen atom? So if you are talking about this particular oxygen atom, it is sp2 hybridized, and this oxygen is sp3 hybridized. How? 2 lone pairs and 2 bond pairs, and both bond pairs are sigma. So total hybridization is sp3. Now, we have observed one thing. This is the oxygen, and this one is the another oxygen. The hybridization is different, but the number of lone pairs are same. And it is having 2 lone pairs, and this one is having 2 lone pairs. So on a single oxygen atom, there are 2 lone pairs. So just count the number of oxygen atoms. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And if you are logical enough, you can directly say the structure is of P4O10. So no need to count even the oxygen atoms. So 2 lone pair, or you can say pair of electron over the single oxygen atom. So there are total how many oxygen atoms? 10. So 10 into 2, 20 electrons are there. Is that clear? 20 electrons pair are. Exactly. So this is 2 electron pair over a single oxygen atom, and there are total how many oxygen atoms? 10. So 10 into exactly. So there are total how many pairs? 20 pairs, and number of electrons are 40. Is that clear? So I hope this video will help you a lot in oxides of phosphorus. Thanks, sir.